unmute. How about now? How about that? Yeah. Sorry, guys. Hey, look, everyone's. Oof. Like, excuse that. All right. Sorry, guys. Anyways, I've been so good at checking it too. It's interpretive math. So the maximum is at 1.811 and 96.771. Those are very likely approximate, but that's all right. And so when x is, but you know what? You know what? I will mute you, Megan.
Thank you.
There. Better, I think. It's like the radio. When x is 1.811, the volume is maximized to 96.771. I guess we should put on inches.
Yep.
And inches cubed, right? Throw on some, because they're all in inches. We don't do inches. Your calculator, I'm pretty sure, probably only does inches.
There's some conversions in it.
Yeah, right? I don't know. In the lengths. All right, cool. So there you have it, a polynomial in action. You're able to graph it, maximize it. If you had to, you could manipulate the graph or even draw it, but nah. How about?
Is there a way that we're ever supposed to get that 1.811 without decimals?
No.
Okay.
Yeah, no. No, unless I show you how to do it mathematically. But I mean, in all honesty, you should be using calculus for that. And that's not what we're doing here.
Yeah.
So we use Desmos. But yeah, so if that was something that I wanted you to do, right, I would, on a test, I would have to give you the graph of Desmos or something like that, right, with all those points. All right, any questions about polynomials? We were kind of in and out. We're going to start chapter 5, which is not graphing. Can I get a what? What? No one likes graphing. All right, chapter 5. We are going to deal with some functions, right? What can we do? Function arithmetic, function composition, and then next day inverses of functions. And so just kind of getting a real handle on functions before we move into exponential and logarithmic curves. Fun. Chapter 5. I realized I had asked you to skim 5.1, 5.3, and 5.6, but then I went over the learning outcomes, and it looks like we should be doing 5.2, so I don't know what happened there, because I've just kind of inherited this stuff. And 5.1 is just kind of a review of what's a maximum, what's the domain, what's the range, that kind of thing. So I'll say see section 5.1 for a brief review. Of domain and range. And mostly the max and the min of functions. It is nice because it gives you kind of a brief overview of everything, and so that's nice. Anybody got time for that? Function arithmetic, here we come instead. Riveting. All right. Function arithmetic is exactly what it sounds. We're just doing arithmetic, so adding, subtracting, multiplying, dividing with functions, right? And so not inside the functions, but the actual functions themselves. And so we'll start with kind of the groundwork. Suppose f and g are functions, and x is in the domain of f and the domain of g. F and the domain of g. We can find the sum of f and g, and we denote it by f plus g in brackets and then of x. But what we do is we just say that's the same as f of x plus g of x. So f plus g of x is a function itself, right? But it's just f of x plus g of x. Same idea, the difference of f and g, we can say that that's f minus g of x, which again is just going to be f of x minus g of x. No surprises there. In fact, there won't be any surprises, right? We just need to establish these things. The product of f and g, but I'm also writing these out just so that you see, right, the sum, the difference, the product, and the quotient kind of in action, those words, right, because we'll start using them more and more. So the product of f and g is fg of x, which is the same as f of x times g of x. And then because I've managed to sink into this page break, I'm going to scoot this up a line. I know, things got tight here. The quotient, oops. The quotient of f and g is f over g of x, which is the same as f of x over g of x, provided, right, as soon as we're dividing, we have to make sure that we're not dividing by 0, right? That's illegal math. And so provided that g of x is not equal to 0. Okay. Right. I guess I've been putting pink boxes around kind of definitions like this. So there she be. Oh. So what we're going to do, we're just going to work through a couple of problems with some functions, and they're going to have different forms. So consider, or I guess here's an example. Consider there's going to be 4 functions. F of x, which is going to be 6x squared, oops, 6x to the 6, made it significantly harder, minus 2x. G of t is 3 minus 1 over t, as long as t is greater than 0. One thing to note, right, is that g doesn't have to be of t, right? G could be of x. Then g of x is 3 minus 1 over x, right? And x has to be greater than 0. So the function itself doesn't change. We can, whatever we call that variable, it doesn't matter, right? And the function h is going to be just the set of points, right? So only at these points is where h is going to be defined. Everywhere else, it's undefined, okay? And so it's defined when x is -3, then y, or h is 2. When x, or whatever the independent variable, is -2, h is 0.4, 0, √2, and 3, -6. See if I can squeeze that in there.
Are you just choosing random points for it?
Well, the book did.
Oh.
Yeah.
Sorry, what's the last one you said?
3, -6. I know, I started lofty, and that's always my mistake.
You had any paper on the left side?
No, none at all. See? And then the function s, whose graph is below. All right. And so, well, I'm giving you the graph. We're going to need to go from at least -2 to +3 on the y-axis, just so you can plan out your sketch here. And from at least -2 to, let's say, +4 on the x-axis, right? So I'll say 3, 2, 1. -1, -2. Keeps going, of course. 1, 2, 3, 4. -1, -2. Definitely not perfect, but it works. Okay. I use a different color just to put these points on. So the first point is closed at -2, -2. Okay. Meaning -2, -2 exists, but it also ends there, right? And then we've got a straight line to 0, -2. It crosses the x-axis at 1, 0. And then it ends, or this line ends at 2, 2. So I guess I can and then after 2, 2, it's a constant function at y equals 2, oops, forever, indicated by the arrow. So here, right, we've got essentially 3 different ways of presenting a function, right? A function could be just from a graph. It's a little bit weird, right? Obviously, we could write this out as a piecewise function if we had to, right? But we'll be able to gather all the information that we need from this graph for S. H is just points, right? I think 1, 2, 3, 4 points, right? Everywhere else it's undefined. And then f of x and g of t, they're just the functions that we expect to see, right? Or in that form that we expect to see.
Is the -3, +3, -6 represented anywhere? Or those just relational things?
In H, do you mean?
Yeah.
Wait, -3.
Okay, so the points that are listed there aren't graphed.
No.
Okay.
So that one is completely separate. We could graph them, but it would just be 4 points on the plane. Yeah. All right. So what I want us to do for question 1 is find and simplify part A, f plus g of 1. You know what I'll do? Just so, because you guys probably have it on your sheet, but while you try to work through that one, I'll copy these functions onto the board so that we can just have them. Hopefully I don't copy them wrong. I'll block this. All right. So by the rules that we just talked about, that we started with, right, we can rewrite this as f of 1 plus g of 1. Right. F of 1 is f evaluated when x is 1, right? And so f of 1, I'm going to put all inside brackets, right? And so you're going to be really careful about your brackets, right, to wrap up all your individual functions. Question or stretch hand?
No question.
Okay.
It would not matter if they have different variables, like you have e for g, and then you have x for f, but either way, they both be 1 in this case.
Yeah, so either way, they're going to take an input of 1, regardless of if it's x or t, or we could even rewrite g of x as 3 minus 1 over x if we wanted to, right? But we don't have to, because we're just saying each of you gets an input of 1. Right? And so f of 1, let's start there, is 6 times 1 squared minus 2x, x is 1, plus g of 1 is 3 minus 1 over 1. So we've got 6 times 1 minus 2, so 6 minus 2 plus 3 minus 1. We get 4 plus 2, which is 6. Same idea. If we want to find s plus g plus h of 3, the same rules apply, right? You can treat s plus g as one function. Remember, they're just making more functions, right? So you can treat s plus g as a single function plus the function of h, but then you can expand the s plus g function as well, right? And so we can expand this out and say that, well, we can rewrite this as s plus g of 3 plus h of 3. Same idea as before. But then s plus g of 3 is s of 3 plus g of 3, and then plus h of 3. Skipping this page break and kind of giving myself more room. S of 3, we only have this graph, right? But S of 3, we take an input of 3, so here, and then we go up and find that the line is constant at 2, right, at that point, right? So it's reasonable to assume that S of 3 is 2, right? So here, I'll just rewrite it because it's a new page for me. But S of 3 is 2 plus G of 3. G of 3 is 3 minus 1 over 3 plus H of 3. H of 3, we have to have an input of 3, right? So -3, -2, 0, and 3. An input of 3 gives us an output of -6, right? And so H of 3 is -6. S of 3, well, my drawing's not very good, but when I put in 3 into S, right, this is S, right, this line here. When I put in 3, I end up at an output of 2. So, we've got this dang fraction in here. Oh, whatever. So I'm gonna put 3 minus 1 over 3 over a common denominator of 3, right? And so 2 plus, and then I'll give myself some more room here. Do you guys remember, I think I saw it a few times on the test, right, where to put it over a common denominator, you were using the trick that I like, which is 3 over 3, right? So 3 times 3 over 3 minus 1 over 3. Right? Just because I want to have a denominator of 3 in order to, I guess, subtract these, -6. With a little bit of regrouping, right, I can group 2 and -6, so I don't have to put them all over 3, right? I can just rewrite 2 minus 6 as -4, right, and just deal with that. And so I've got 3 times 3 is 9 over 3. I think we can all agree that 9 divided by
9 times, or 3 times 3.
Yeah. What did I say? Oh. Yeah, I don't know. Man, oh man. Okay, 9 over 3 is 3. Yeah? Great. -1 over 3. I don't know. And then -4, right? Combining 2 and -6 into 1. I like to slim down this fraction, but you totally could put 4 over 3, right? And rewrite it as -12 over 3, right? That's fine. But I'm gonna, 9 minus 1 is 8 over 3, -4 times 3 over 3 8 over 3 minus 12 over 3. Now I can simplify. 8 minus 12 is negative 4 over 3. All right. Any questions about that one? Ready to kick it up a notch? Let's do it. Sounds great. F plus H over S of 3. A blip. Ready to kick it up a blip? So again, I would treat the F plus H as one function until I can expand it, right? And so I get F plus H of 3, right? The rule says that I can just split up these functions in the numerator and the denominator over S of 3. And then I can rewrite F plus H of 3 as F of 3 plus H of 3. And then over S of 3. I'll scoot over to give myself more room. F of 3, again, is 6 times, or I guess not, again, F was with 1. So anew, 3 squared minus 2 times 3 plus H of 3, that's a negative 6.
So will they always give you the H then? So it doesn't give you one value, you can find the other, right?
Yeah. Because if I said, okay, find H of 2, right? H of 2 is undefined because it's not in the list, right? And so you wouldn't be able to work with that. I wouldn't do that. Yeah. Nice, right? And then again, S of 3 we decided was 2. So the only new player is F of 3. So we can solve, there we go, because I've had no luck. 6 times 9, oops, and then I did 9 times 9. 54 minus 6 over 2, right? Adding a negative. 54 minus 6 is 42. 42 over 2 finally lands us at 21. Okay, nice. All right, so let's incorporate the domain into this. Find the expression for the function g over f of t and state the domain. All right. So we'll start with the function and then we'll talk about the domain. All right. So the quotient of g and f, start over here, g over f of t. Right now we're not plugging in some value, we're just using t as our input. And so g is already in terms of t, right? But f is in terms of x, but we can just rewrite f of t as 6t squared minus 2t, right? So we can just swap those out because now we're saying the input is t. Great. From our little rule book, right, we know that we can rewrite this as g of t over f of t. G of t is 3 minus 1 over t over f of t, which is going to have to be 6t squared minus 2t. What we're going to have to do, right, to kind of simplify this thing is I'm going to put this, right, as one fraction, and then technically this is a fraction, 6t squared minus 2t all over 1, right? And then I've got a fraction over a fraction, which I can flip and kiss, right? And so let's do it. Same idea, right? If I want them 3 minus 1 over t to be all over t, right? I can multiply 3 by t over t. Right? Same applies, or same rule applies. 3 times, maybe I'll put it up high a little bit. 3 times t over t minus 1 over t, because t over t is still 1. Right? So it's still legal math over, and I'm going to write 6t squared minus 2t all over 1, just to show that, in case it's not clear, that we will have a fraction over a fraction. So we've got 3t over t minus 1 over t, showing way more steps than I need to. 6t squared minus 2t, technically over 1. I can combine that top with 3t minus 1 all over t. 3t minus 1 all over t, because we've got that common denominator. And then over 6t squared minus 2t over 1. To divide fractions, right? You got fraction over a fraction, you're gonna flip and kiss. And so we've got, this becomes 3t minus 1 over t times 1 over 6t squared minus 2t, right? That bottom one's been flipped. And then we multiply through. Multiplying fractions, then we can just multiply across. Right? And so we get 3t minus 1 times 1 is still just 3t minus 1 over t, and I'll just put the 6t squared minus 2t in brackets for now. 6t squared minus 2t. I can pull out, what can I pull out? I can pull out a 2t from these, right? At least in the denominator. And so I rewrite this as 3t minus 1 over t times 2t. If I pulled out 2t from 6t squared, I get 3t. And then if I pull out 2t from 2t, I'm left with just 1. Because when I'm pulling it out, I'm actually dividing. The only reason I did that is because it conveniently cancels the 3t minus 1, right? Because I've got 3t minus 1 as well, it's on the numerator, but also as a multiplier in the denominator, right? And so I'm allowed to cancel them. Only if I'm multiplying, only if I'm multiplying, right? All the way through. Okay. So this cancels with this. So now I'm left with 1 over t times 2t. Let's just write that as 2t squared. The pickle with these things is if I asked you what's the domain of 1 over 2t squared, right? You would probably just say, well, t can't be 0, moving on, right? Only because the rules for the domain say, well, we can't have illegal math. So the two main things to look out for is we cannot divide by 0 and we cannot take the square root of a negative number, right? And so when working with the domain, we need to keep an eye out for values that yield illegal math. Number 1, dividing by 0, bless you. Can't do that, right? So any input that's going to make you divide by 0 cannot be in the domain, right? Same thing, right? The square root of a negative number. We can't deal with those. Imaginary numbers. Huh? So those are your main things that you have to keep an eye out for. But we also said that, okay, well, x has to be in the domain of f and g, right? So whatever the original domains were of f and g, those hold steady, and we can only use the overlap of the two, right? And so we can only use the overlap of the original domains. And so the original domain of f of t, remember, is 6t squared minus 2t. The domain of that thing is anything goes, negative infinity to positive infinity, right? I'm not dividing by 0. I'm not taking the square root of a negative number. It can handle anything unless, you know, the blurb says otherwise. But if it's just like this, it can handle anything. All real numbers. G of t, remember, was 3 minus 1 over t. And it came with the domain, right? We were told that t has to be greater than 0. Right? Or if we wrote it in interval notation, we would have from 0 to infinity. Right? What I saw a lot of on the test was just kind of swapping the order here. We have to go from smallest to largest, right? And so always write them from smallest to largest.
Well, this would be a negative. You could have 1 divided by -1.
You can, but because we were told in the question that t has to be greater than 0, like it was part of the function that we defined, so that's what's saying that we can't have a negative. And then we know that t also can't be 0, right? So that's why it's exclusive of 0, right? And so now, if you put the round bracket, it means it can go very, very close to 0, but it can never actually be 0, right? That's what that round bracket means, right? Just like we can get very, very close to infinity, but we can't get there, right? So combined, our, let's say, largest domain is, well, f could take from negative infinity to positive infinity. G says, well, I can only handle from 0 to infinity, so combined, right, any combination of the two can only go from 0 to infinity, right, is from 0 to infinity.
You just choose the highest value between them then?
Yeah. No, the smallest, all the overlap.
Yeah.
Yeah.
So
Which I think is what you meant.
Yeah, like
yeah.
0 being the highest, it could be on the low side, and then infinity, it would both be
exactly. So they can both go to
but
infinity.
if one was less than infinity, then you have to go with that number.
Exactly. So say f was from negative infinity to 4, and g was from 0 to infinity, right? We would be from 0 to 4. Right. So combined, right, our largest domain that we could have is from 0 to infinity, right? But also, our function was, oh, where is it? G over f of t. So another condition is that f of t can't be 0. Right? And so we need to kind of look at the layers and say, in our function, g over f of t, we know f of t cannot equal 0. Any values of t that make f of t equal to 0 will need to be removed from the domain. From the domain. Okay. You've already done a lot of work finding the zeros, right? And so this is essentially just finding the zeros, right? Where does y equal 0? And so f of t is 6t squared minus 2t. And I'm going to force it to be 0 and solve for t. Figure out which values of t, and there will be 2, make this 0. But this is just the quadratic equation, right? And so, yeah, you could go ahead and factor it. I hate factoring, so I'll always, if I've got a polynomial degree 2, yeah, I'm going to use the quadratic equation, right? Because that's my, I know I'll get it that way, right? It's longer, but if you see the factoring, that's great. Good for you. But me, no. I'll say we can use the quadratic equation, which negative b, if you haven't memorized it already, I don't know. Negative b plus minus b squared minus 4ac over 2a.
So you just put 0 into that equation, and there you got your ABC.
Yeah.
So
plus 0.
Plus
yeah, yeah. So here, yeah. A, B, and then technically we have plus 0, which is your C. We're still solving for when it equals 0, so I would leave that on the right-hand side or kind of equal to, but all right, so we get negative 2 plus minus the square root of negative 2 squared minus 4 times 6 times 0. Phew. Why would I say phew? Otherwise, we'd be taking the square root of a negative number, and that's not going to work. 2 times 6 in the denominator. And so we've got negative 2 is just 2 plus minus square root of 4 minus 0 over 12. So we get 2 plus minus 2 over 12, which is going to be 2 minus 2 over 12 and 2 plus 2 over 12. 0 and 4 over 12, which is 1 over 3. All right. So we know that our function, our new function, will not be able to handle t's of 0 or 1 over 3. Okay. So therefore, our new function will not be able to handle t equals 0 and t equal to 1 over 3. Recall the domain, right? The combined domain of f and g was from 0 to infinity. All right, now we need to dice this up a little bit. So t equal to 0, that's a non-issue, right? Because we're already saying, no, t can't be 0, so moving on, right? And so this one is taken care of. But now we have to remove t equals 1 over 3. So what we've got is we've got from 0 to 1 over 3, that's fine. And then we do a skip to 1 over 3 to infinity, right? As long as it's not equal to 1 over 3, then we're safe, right? And so we write the domain as from 0 to 1 over 3. And then we do a U for the union. And it just is a way to link up all these different intervals. And then we start again from 1 over 3 to infinity. Oh, that was a crappy infinity. So as long as we're not equaling 1 over 3, right? So we don't have a square bracket, we can go from 0 very, very close to 1 over 3, and then we can pick up again very, very close to 1 over 3 on the other side and go to infinity. So this is different, right, than the domain that we would have said if we had just looked at the new equation, which was what? Where is it? 1 over 2t squared, right? Just looking at that, we would say, well, t can't be 0, moving on, right? But the domain has to take into account the original 2 functions, 2 or 3 functions, depending on what you're dealing with, right? As well as the combination that you've got, right? So like I said, the domain, it requires a little bit of work, but as long as you're working through it methodically, right, figuring out what the original domains were, what the overlap is, and then if there are any new values that can't occur because of your new function, right, then you can weed those out, and then you've got your fancy new domain. Right. Any questions about that? No? Let's talk a little bit about difference quotients, which we've seen already. Difference quotients you did the average rate of change on the test, right? The average rate of change is a difference quotient, right? Because we've got a difference over a difference, right? Making it a quotient, but also it's often when we're talking about the change in f of x over the change in x, right? So recall the average, oops, the average rate of change of a function over the interval inclusive from a to b is the slope between the 2 points a f of a and b f of b, and is given by the change in f of x over the change in x, which is f of b minus f of a over b minus a. So we've got a difference over a difference quotient. Expressions like these are generally called the difference quotient of f since it is the quotient of two differences. Surprise. Namely, the change in f of x, so delta f of x, and the change in x, delta x. Example. For f of x equal to x squared minus x minus 2, find and simplify. Find and simplify. Part A, I want you to find f of 3 plus h minus f of 3, oops, minus f of 3 over h. It's getting eerily close to calculus. Limit definition of a derivative.
That's learning.
Yeah. Though we timed our our sound effects perfectly. Although I think the sentiments were a little bit different. So if you have to write f of 3 plus h, what you're going to do is you're going to write f, but instead of x, you're going to replace every x with 3 plus h, right? Just the same way that we did with f of 3, right? But you want to really keep your wits about you because things get messy. So if you're doing f of 3 plus h, I'm going to put f of 3 plus h in big brackets. And wherever I see an x, I'm going to replace it with 3 plus h. So 3 plus h squared, right? Being careful that you're squaring the entire 3 plus h, right? Otherwise, well, it'd be wrong. Minus 3 plus h minus 2. Okay, so that's f of 3 plus h. Doing the same thing with f of 3, right? I get 3 squared minus 3 minus 2. A little bit easier on the eyes. And then over h, that's great. Okay. This is a difference quotient, right? Because we moved from point A to point B, right? And so down here, we've got B minus A, which is 3 plus H minus 3, which is just H, right? So it's already simplified, right? But we've moved just up H spots from 3, right? All right, now to simplify this, and like I said before, but then I botched it, but I'm still gonna do it nice and slow, right? The 3 plus h times 3 plus h, I like to write them out, right? There's no point in missing anything. And so I'm gonna write 3 plus h times 3 plus h to try to expand this thing because we have to simplify it all. And then minus, you know what? I'm gonna bring that negative inside. Minus 3 minus h and then minus 2. Right. Careful that you bring that negative onto both the 3 and then the h. And then that's my f of 3 plus h. And then minus 9 minus 3 minus 2. I said it, but I wasn't listening. 9 minus 3 is 6 minus 2 is 4. And then over h. Gonna deal with the 3 plus h times 3 plus h. And so I get 3 times 3 is 9 plus 3 times h plus h times 3. I'll just write 3 times h again, plus h squared. Minus 3 minus 2, I can simplify to minus 5 and then minus h. And then minus 4. Right. So slowly on the different levels, I'm dissolving these brackets, paying attention to negatives and things. Okay. So what I'm going to do is I'm going to group all my like terms before I start simplifying, but I will ditch these brackets. And so I've got h squared plus 3h minus h, and then plus 9 minus 5 minus 4, all over h. I'm going to count these out. So the reason I didn't simplify them already is because I want to count them out and make sure that I have all the terms, right? And so I've got 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 5, 6, 7. That's a relief. Hopefully they're right. H squared, 3 plus 3 minus 1 is 5. Plus 5h. 9 minus 5 minus 4 dissolves, and then over h. I can pull out a common h in the numerator, right, and rewrite this as h times h plus 5 over h. And that's always going to happen if you're dealing with things like this. You're going to be able to cancel that h in the denominator. So we get h plus 5, h plus h, yikes, h plus 5. So that is the difference quotient of f of 3 plus h minus f of 3 over h. Right. Just undoes itself to h plus 5. Okay. All right. What about another one? Very similar, but just a general one. F of x plus h minus f of x over h. Go through and do the same thing again, but just with a general x. Oh. I use that f of x. X. We're on to a different f of x, aren't we? Oopsies. Let's erase this just so I don't do that again. That's better. Hey, this doesn't make sense. There we go. Minus x plus h minus 2. Let you guys plug away. I'll plug away as well, and then we can check our work. I got them all. Gotta catch them all. You're right. It's Pokemon Go.
Sorry, those. There's a call for
So old news then. Obviously, I'm showing a bit more work than you have to. You don't have to show the zeros, but I just want to show where things went. Finally. And once more, we can pull out that common h. 2x plus h minus 1. Oh. So that's the general difference quotient for any f of x minus f of x over h. We can check, right, because in part A, we had x equals 3, right, and we found that it should be 5 plus h. Right? So we can check when x equals 3, we should get 5 plus h, right, and 2 times 3 plus h minus 1 is 6 minus 1, 5 plus h. If I could insert emojis, I would. And it would be the little like smiley sweaty one. Phew. I know, I think I should be, well, maybe. Let's see here. Maybe this one. Cut. This is totally worth it. Okay. Oh, we did so much. Look at you guys go. It's in the bottom, it's in the wrong corner, but that's pretty good. Dun, 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 dun. That's you guys on your hydrology midterm. Anyways, we'll do too soon. We'll start 5.3 next day, function composition, and we'll do 5.3 and 5.6. But I'm gonna let you go and worry about your midterm. How about that? Get to what? Congratulations. Oh. So you're like, good luck on your midterm, guys. See ya.